A pleasant greetings to all. In this video, I am going to explain symmetrical component and matrix notation of the symmetrical component. Symmetrical component. The majority of the faults in power system are asymmetrical. To analyze an unbalanced fault, an unbalanced three-phase circuit has to be solved. The direct solution of such a circuit is difficult and also tedious and time-consuming. The solution can be more easily obtained by using symmetrical component. That's why we go for symmetrical component. Next, I am going to explain general principles used in the symmetrical component. Any set of three-phase voltage or current can be transformed into three balanced sets. First one is positive sequence set, second one negative sequence set, and third one is zero sequence set. Next, I am going to explain the operator A. The operator A plays a major role in symmetrical component analysis. How to write the operator A? A equal to 1 angle 120. It can be written as 1 e power j 120 or e power j 2 pi by 3. And next I am going to find out A square. A is multiplied another one A will get A square. So what about A square? 1 angle 120 into 1 angle 120. That is equal to 1 angle. Add these angles 240 degree. So how to write this? Cos 120 plus j sin 120. What is the value of cos 120? It is easily find out by means of all silver tea cups. Here sin, tan, cosine all are positive. Here sin only positive. Remaining tan and cosine are negative. Here tan only positive, remaining all other sine, cosine components negative. Here cosine is positive, remaining are negative. So cos 120 degree plus j sin 120 degree. How we can write this? Cos of 90 plus 30 plus j sin 90 plus 30. Next I can written as 1 into 90 plus 30 plus j sin 1 into 90 plus 30. So 1 is the odd number and this is cos. So in the second quadrant, sin only positive and cos is negative, so minus. Here 1 is the odd number, no, cos is changed into sin. Minus sin 30, here the sign is positive, so j, here also 1 odd, so it is changed into cos 30. What is sin 30? That is 1 by 2, 0.5 plus j into 0.866 because root 3 by 2. Root 3 means 1.732 divided by 2, that is 0.866. So this is the equation for rectangular form of operator A. So this is the polar form of operator A. This is the rectangular form of operator A. Next, in the similar manner, I am going to find out A square. A square is cos 240 plus j sin 240. How I can write this? Cos of 180 plus 60 plus j sine of 180 plus 60. So cos of 2 into 90. I can write 180 as 2 into 90 plus 60 plus j sine of 2 into 90 plus 60. So 2 is an even number. And what is 240? 240 means 90, 190, 270. So tangent is positive, remaining all are negative. So minus. So 2 is an even number. There is no change in the cos. So cos 60 plus tan only positive. So here all this is negative minus j sine. Here this is even number. There is no change of sign here. So sine 60. What is minus cos 60? That is minus 0.5, 1 by 2 minus sine 60 is root 3 by 2, that is 0.866. So this is a square. Then the third one is a cube. Multiply a square into a will get a cube. A square is 1 angle 240. And what about A? A is 1 angle 120. So answer is 1 angle 360. Now I have to expand this. So cos 360 plus j sine 360. So cos 360, how we can write this? Cos of 4 into 90 plus 0. And next, how to write this? J sine of 4 into 90 plus 0. Here this is even number. There is no change in cos. So cos 0. But it is in the cos fourth quadrant only. There is no sign change. And here there is a sign change. The fourth quadrant cos only positive. Sine 0. So what is the answer? Cos 0 is 1. J into sine 0 is 0. So a cube is what? A cube is 1. Next I am going to find out a power 4. How we get a power 4? A power 4 is, can we write a power 4 as a cube into a? So what is a cube? A cube is 1. So 1 into a. What is a power 4? A power 4 equal to a. So next I have to write a power 5. How we can write this? A power 5 is a cube into a square. Can we write a cube is 1? Can we write a power 5 as a square? And next from this, what is 1 plus a square? So a is equal to 1 minus 0.5 plus j 0.866. What about a square? Minus 0.5 minus j 0.866. Minus 0.5 minus 0.5 is 1110. Cancel. Here plus j minus j cancel. So another relation we got here. 1 plus, that is 1 plus a square equal to 0. Then a cube equal to 1. Then a power 4 equal to a power 5 equal to a square. These relations we got from the operator a. And next I am going to explain the three components. Three components are positive sequence component, negative sequence component, and zero sequence component. In a positive sequence component, VA1, VB1 and VC1. The angle difference between any two faces is 120 degree. The clockwise direction means that is negative angle, anti-clockwise direction positive angle. What is the sequence of the positive sequence component? A, B, C. And see, this is the negative sequence component. Here the sequence is A, C, B. This is the negative angle and this angle is the positive angle. See the zero sequence component. There is no phasor difference between zero sequence component. Okay. These are the three different sequence components that is in the symmetrical network. Then how to draw the unbalanced voltage set? See, the unbalanced voltage VB is equal to, first write VA equal to VA0 plus VA1 plus VA2. VB is VB0 plus VB1 plus VB2. So this unbalanced voltage consists of all the three components. Unbalanced voltage VB consists of all the three components and VC consists of VC0, VC1, VC2. So first of all, how to draw VA? Here this is VA, VA1, then this is VA2, both are added and that is added with VA0, we get VA. And next see VB. So VB1, it is combined with VB2 and then VB0, the same direction. See, this direction is same, VB1, then this is this direction, VB2 and see this direction, VB0. These three are combined together to form VB. And see VC, this is VC. Okay, here VC1. Next, this direction, see, this both are same direction. VA2, 2. So VC2, then VC0. All are combined together form VC. Okay, these are about the three unbalanced voltages are equated with the three components positive, negative and zero sequence component. Next I am going to explain the matrix notation for the unbalanced voltage and the symmetrical component. So first this is VA1, VB1 and VC1. This is the positive sequence component. Next, negative sequence component VA2, VC2 and VB2. This is zero sequence component. So how to write this? VA equal to VA1 plus VA2 plus VA0. Okay. Or otherwise I have to write VA equal to, first write VA0, next VA1 and third VA2, equation number 1. Next what is VB? VB equal to VB0, VB1 plus VB2. I have to write VB0, VB1, VB2 in terms of VA0. What is VB0? VB0 equal to VA0. What is VB1? VB1 equal to, see this is VB1. So how to write VB1 in terms of VA1? So VB1 equal to, you see, this is A. A means 1 angle 120. This angle is 1 angle 240, that is A square. So VB1 can we write like this, A square into VA1. And next, what is VB2? VB2 equal to, how to write VB2? VB2 equal to A into VA2. 1 angle 120. A into VA2. So how to write VB now? VB equal to VA0 plus A square into VA1 plus A into VA2. This is the equation number 2. These equations are very much important. VA, VB. These are the equations for unbalanced voltage. Then write VC. VC is what? VC0 plus VC1 plus VC2. So VC0 equal to what? VA0. VC1 how to write? VC1 equal to A into VA1. And what is VC2 in a negative sequence component? A square into VA2. A square into VA2. So VC is the unbalanced voltage that consists of the components zero sequence component, positive sequence component and negative sequence component. This is the equation number 3. Now I am going to equate unbalanced voltage with the 3 symmetrical components. So VA, VB, VC here, the left hand side, right hand side I am having 1 or VA0. So I have to write like this 1, 1, 1. Here VA0, VA1, VA2. 1 A square A, 1 A square. Okay, so VABC is the unbalanced voltage that is equal to the matrix A into V012 is a symmetrical component. So once again I have to write A is equal to 1, 1, 1, 1 A square A, 1 A square. Now our equation is unbalanced voltage VABC equal to A matrix into 0, 1, 2. Next, have to multiply A inverse on both sides of the equation to find out the symmetrical components of the voltage. So VABC that is equal to A inverse into A V012. What is A inverse into A? That is the identity matrix I. So V012 equal to A inverse into VABC. So this is the equation which is used to find out the symmetrical component in relation with unbalanced voltage. Okay. So next, how to find out the A inverse? What is A inverse? A inverse is adjoint of A divided by determinant of A. So this is the very tedious process. So I have to use the shortcut method to find out the A inverse. So first of all, I am going to find out determinant of A. So 1, 1, 1, 1 A square A, 1 A square. What is the determinant? 1 of A power 4 minus A square. Then minus 1 of A square minus A plus 1 of A minus A square. So A power 4 minus A square minus A square plus A minus A square. What about A power 4? A power 4 is equal to A cube into A, or simply we can write A. A minus A square minus A square plus A minus A square. So 3A minus 3A square. So 3 of A minus A square. After getting the value, how to find out the A inverse? So what I have to do, first of all, I am going to write row 1, row 2 and row 3. 1, 1, 1. 1 A square A. 1 A square. Once again have to copy the row 1, column 1. First write column 1, column 2, column 3. Column 1 once again have to copy down. And next have to copy down the column 2 also. Next the first row element is copied down again. And next the second row element is copied down again. A square A, 1 A square. Next I am going to explain how to reduce this. So once again I am going to write column 1, column 2, column 3. Here row 1, row 2, row 3. Okay, column 1, 1, 1, 1, 1 A square A, 1 A square, 1, 1, 1, 1 A square A. Then copy the first row 1, 1, 1, 1, 1, 1 A square A, 1 A square. So first I have to cut this. To find out the adjoint of A, have to cut this values. And then what I have to do? A square minus A power 4. Have to write the matrix now. Okay, already I got the determinant. Determinant equal to 3 into A power 4 minus A square. Or 3 into A minus A square. Already I got the answer. Okay, next how to find out the value? Here A power 4 minus A square. Multiply in the column ways but write in the row ways. A minus A square. Okay, next A minus A square. The first row is completed. In the similar manner write A minus A square. And then write A square minus 1. Then 1 minus A. Okay, next A minus A square. Third row and 1 minus A. Then A minus 1. Okay, see here. In this way, have to complete everything. And after finishing this, what I have to do? I am going to find out the matrix. So, have to rewrite like this. A square minus 1. a square minus 1. How I can write a square minus 1? A square minus 1 I can rewrite as a power 5 minus a cube. So if I take a in this inside, the answer is a power 4 minus a square. So a into, what about a power 4? A minus a square. So instead of a square minus 1, I have to put this value. And instead of 1 minus a, how to write? A cube. A cube is 1. How to write a? A is a power 4. Already I have explained a cube into a. Have to take a square outside. So a minus a square. Okay, instead of 1 minus a, have to write like this. Okay, next. This is a square minus 1 because this is a square. Okay. Next I have to rewrite this. How to rewrite this? 1 by 3 into a minus a square. Inside, what are the terms? The terms are a minus a square, a minus a square, a minus a square, a minus a square into, instead of a square minus 1, I am writing as a minus a square. Instead of 1 minus a, I am writing as a square, a minus a square. And then instead of a minus a square, 1 minus a square into a minus a square. And here a into a minus a square. Okay, now how to write this? Have to take, which one is common? A minus a square is common. So I have to take it outside. 3 a minus a square. So inside, what are the terms? 1, 1, 1, 1, 1. Then here a square, a. Okay, this is B 0, 1, 2 in terms of B, A, B, C. So B012 is a symmetrical component that is related with 1 by 3, 1, 1, 1, 1 a square, 1 a square a, B, A, B, C. Okay, that's all. This is the relation between symmetrical component with unbalanced voltage. And already I have explained the relation between VABC and this B012, that is 1, 1, 1, 1 a square a, 1 a square. That's all. Thank you. Have a nice day.